The Ultimate Factoring Series, Lesson 7, Factoring by Grouping. In Lessons 1 through 4, we focused almost exclusively on binomials. That's expressions with two terms. In Lessons 5 and 6, we focused exclusively on trinomials. That's expressions with three terms. So here in Lesson 7, we're going to expand it to more than three terms and what we should do then. It's important when you're told to factor to look at how many terms you have, because that gives you a big hint about how to approach the problem. If you see that it's a binomial, you probably want to think about the methods you learned in Lesson 1 through 4. Check for the greatest common factor. Maybe it's a difference of squares, difference of cubes, or sum of cubes. Or if it's a trinomial, you know you need to set up the two sets of parentheses and then figure out how to change it to two binomials. It's kind of like reverse FOIL at that point. Or you can use one of the methods you learned with guess and check, bottoms up, or even the box method. So now that we're moving on to more than three terms, we're going to try a method called factoring by grouping. You can see here I have four terms. So at this point we would just call it a polynomial. If it's got more than three, they just call it a polynomial. Poly means many. So this is a polynomial, and when we're factoring by grouping, we tend to put things in pairs. So I'm going to put this as a pair, and I'm going to put this as a pair, and for a moment I'm going to basically treat it like two different problems. I'm going to treat it almost like I did back in Lesson 1, where I was just looking for the greatest common factor. So focusing just first on the first two, 2r cubed minus 10r squared, I say, okay, what would be the greatest common factor? What is something I can factor out of both of those terms? Well, I can factor out a 2, and I can pull out an r squared. Now that will leave me with an r minus 5. If you're not sure, you can always distribute that back out and check. 2r squared times r is 2r cubed. 2r squared times negative 5 is negative 10r squared. So that works. Now let's look at the second pair and say, okay, what can I pull out that both of those have in common? What is their greatest common factor? And that would be a 3. So if I factor out a 3 here, that leaves me with r minus 5. Like I said, for that moment I was basically treating that like two different problems. Well, now that I've got that done, I go back and treat it as one big problem. And now I'm down to two big terms, one term here and one term here. And if you notice, they have something in common. They have r minus 5 in common. Both of them have r minus 5. So I'm going to factor out r minus 5, and that will leave me with 2r squared plus 3. And that is my final answer. If you want to check this by foiling, you certainly can. Multiply the first, outer, inner, last, and combine the like terms, and you should get back exactly what we started with up here. Next one, 12x cubed plus 2x squared minus 30x minus 5. I notice that there are four terms, so since there's more than three terms, I think factoring by grouping. As soon as I see that there are more than three terms, I think factoring by grouping. So I group them into pairs, and I say, okay, what do 12x cubed and 2x squared have in common? What is their greatest common factor? That would be 2x squared, leaving me with 6x plus 1. Now be careful, there are lots of people, if this is the greatest common factor, they just kind of make it disappear and they want to just write 6x. But that's not right. Because think about it, if I multiply these two back together, I don't get both of these terms. If you watch the very first lesson I made on this, I mentioned that factoring is kind of like dividing. So really, we're doing 12x cubed divided by 2x squared. That's how we end up with 6 and then just an x. And then 2x squared divided by 2x squared would be 1. And if you distribute this, you do get back exactly what you started. So just be careful with that. Make sure you do leave the 1. Now negative 30x and negative 5 is my next pair. they have a negative 5 in common. If they're both negative, pull out the negative. So they have a negative 5 in common, and that will leave me with positive 6x plus 1. So again, I've treated the two pairs almost like two separate problems, but now I treat it as, again, one big problem, with one big term here and one big term here, both of which have a 6x plus 1. That leaves me with 2x squared minus 5. We'll go ahead and check this one just for practice. 6x times 2x squared would be 12x cubed. 6x times negative 5 is negative 30x. 1 times 2x squared is 2x squared. And then 1 times negative 5 is negative 5. Now typically we put these in descending order, in other words put the biggest exponent first and then work our way down. So if we change it to that, you can see that it does in fact match exactly what we started with. So 6x plus 1 times 2x squared minus 5 is the correct answer. On this example, I notice again I have more than 3 terms. If I have more than 3 terms, I think factoring by grouping. So I change them into pairs. And I think, okay, 28v cubed plus 16v squared. What do the two of them have in common? Okay, well, v squared jumps out to me real quick. I got to think a little more carefully about the biggest number I can pull out of 28 and 16. I believe 4 is the biggest number that goes into both of them. That'll leave me with 7v plus 4. Then over here, the negative 21v and the negative 12, the biggest number they have in common is negative 3. That will leave me with 7v plus 4 also. Convenient, right? We keep ending up with the same things in parentheses. Now that we see they both have 7v plus 4 in common, we can pull 7v plus 4 out front. We factor it out of those two terms. And that leaves 4v squared minus 3. And that is our correct answer. Okay, getting a little more complicated now. Still 4 terms. The fact that there's more than 3 terms tells me that it must need factoring by grouping. So I treat this as the first pair and this as the second pair. Okay, first of all, 42 and 36. I believe that 6 is the biggest number that goes into both of them. They both have an A, and that's all. They don't share a B or a D, so that should be it. So I pull 6A out of 42AB, it'll leave me with 7B. If I pull 6A out of 36AD, it'll leave me with 6D. Now I look at the second pair. 7 and 6 don't have anything in common other than 1. There's no reason to factor that out. So it'll just be, well, negative 1 actually. So yeah, let's pull out the negative. We'll go ahead and write negative 1. And they also have a c squared in common. You can also just write negative c squared. The 1's not required. But if I pull out a negative c squared, that'll change that to a positive 7b and a positive 6d. So, yet again, we have a match, 7b plus 6d. If we factor that out, it will leave us with 6a minus c squared. If you want to check it, feel free to FOIL, and you will get the exact same thing back that you started with. Okay, I see here that there's more than 3 terms, so I think factoring by grouping. I separate them into pairs. (105) and 75 have 15 in common, and both of those terms have an x in common. And that should leave you with 7y plus 5. Okay, then 175 and 25 both have 25 in common. Both those terms also have an r in common. That leaves me with 7y plus 5. So, since both of these have 7y plus 5 in common, I can factor 7y plus 5 out, put it out front. And that leaves me with 15x plus 25r. Okay, now we have 6 terms, and I believe this is the last example. When you have 6 terms, you may need to split them up into 3 pairs, or possibly make it 2 sets of 3. Now, here's the way I would suggest you look at it. Let's just try 2 sets of 3. If I look at this is a set and this is a set, I run into a problem because there's nothing that all 3 of them have in common. 2b to the 5th, well, let me back up. 2b to the 5th, 4b to the 4th, and 5b cubed do all have b cubed in common, but their numbers aren't in common. And when I look at the second set of 3, they don't have anything in common. So that kind of sets off a red flag that it's probably not going to be 2 sets of 3 because there's not a lot that can be pulled out. So instead of doing 2 sets of 3, let's try 3 pair. 2b to the 5th plus 4b to the 4th, they have 2 in common, and b to the 4th in common, leaving me with b plus 2. Negative 5b cubed minus 10b squared have a negative 5 in common and a b squared in common, leaving us b plus 2. 7b plus 14 have a 7 in common, which still leaves a b plus 2. So all 3 of these terms have b plus 2 in common, meaning I can factor b plus 2 out, leaving me with 2b to the 4th minus 5b squared plus 7 as my final answer. So anytime you have more than 3 terms and you're told to factor, you need to consider factoring by grouping.